In this video we're going to take a look at complex ions and their shapes. So in your exam you might be asked to define or explain what a complex ion is, so you're going to say so transition element ion, you could get away with saying a metal ion bonded to one or more ligands by coordinate bonds, and this is generally going to be 1 mark. So if we look at an example of what we mean, if we take a central metal ion of chromium and some water ligands, so there's water with its lone pairs. Chromium's obviously got empty d orbitals, so we're going to get the water donating its lone pair of electrons to form a coordinate bond. And this can happen quite a few times around central metal ions, so we get a number of coordinate bonds forming around that central metal. So what we've got forming here is a complex. Now, key things when you're drawing complexes are that the coordinate bonds, exactly like as in F321, must go from the lone pair to that central metal ion. So for example, if I was to draw this in the shorthand version, like this, I could draw those as H2O, so that would be fine here because there's the water and it's the oxygen that's bonding. It'd also be fine here. I could do it here, that'd be okay. But if I was to do that here, then that would be wrong because that shows a coordinate bond forming with a hydrogen. So if I'm going to write it like this, I need to make sure that over on this side I'm writing my water kind of back to front like this, so it's still the oxygen that's bonding to the chromium. If we then look at shapes, so we've got 3 possible shapes in F325. We've got the one that we've been practicing with, which is octahedral. So there are 6 coordinate bonds forming with that central metal ion. The bond angle, exactly the same as at AS, is 90 degrees. We've then also got a new shape for this year, which is square planar. You could see it drawn like that, or like this, or like that. So all 3 of those diagrams represent the same thing. The bond angle here again is going to be 90 degrees. The name of this shape is square planar. And our final shape has 4 bonded pairs, and that's tetrahedral. So you should remember from last year, bond angle here is a 109.5, and it's called tetrahedral. Key things then. If you see anything with 6 ligands, or perhaps 3 bidentate ligands, or maybe even 2 bidentate and 2 monodentate ligands, you're looking at octahedral. If it's a 4 coordinate complex, then you should assume that it's going to be tetrahedral unless the question says otherwise, or you recognise that it is a platinum compound. So in your F325 studies you'll have learnt about cisplatin and you should recognise that that forms square planar complexes, but everything else that's 4 coordinate, assume that it's going to be tetrahedral. Once we've got these diagrams, we'll also talk about coordination numbers. So the coordination number is the number of coordinate bonds formed around the central metal atom. So if we start off by looking over here at the tetrahedral one, count the number of coordinate bonds around the copper. We've got 1, 2, 3, 4. This is 4 coordinate. Look at the platinum. We've got 1, 2, 3, 4. This is also 4 coordinate. Look at the chromium. 1, 2, 3, 4, 5, 6. So this is 4 coordinate as well. Sorry, 6 coordinate. Even if some of these ligands are bidentate, so let's have a look at, if this is bidentate, we still look at the number of bonding pairs, so it's still 1, 2, 3, 4, 5, 6, it's still 6 coordinate. If we went over here and made these into bidentate ligands, it's still got 1, 2, 3, 4 bonded pairs around that central metal ion, it's still 4 coordinate. If you want more practice with drawing complex ions, have a look at the 2 videos on drawing complexes with monodentate ligands and drawing complexes with bidentate ligands for further practice.